Okay, the last question people submitted was 359. So we have a traffic light here. It's hanging in the middle of 3 posts. We have some dimensions and 3 dimensions here. We're given the mass is 20 kilograms. We know the height, the center point there, A, is 2.5 meters. And then we need to find our tension. So this is very similar to that 294 question, just in 3 dimensions. So I'm going to write out the steps here. Step 1, 3-body diagram. Step 2, find unit vectors. Unit vectors. Step 3, then, find the forces. So we'll call it FB, FC, FD. Step 4, apply the equations of equilibrium to that, and then we'll find those tensions. So this step will not be the direct numbers, but we will have these equations in those directions. We know how that works out. We'll start with the z direction, and we'll solve these in terms of the others and kind of find those things. So step 1, the free body diagram. So we've got a stoplight, and it's being held off this direction, this direction, and this direction. We've got B, C, and D. Point A. I'm going to write out what the positions of each of these are. And we know that this mass equals 20 kilograms. So I'm going to write out the positions of the point. So A is going to be, what are we in the x direction? Call that 0. So there's 0 in the y direction, 0 in the x direction here. So we have 0, 0, 3.5. B equals, we have positive 3x, positive 4y, and 4 meters for the last point. So there's our 4 meters in y, 3 meters in x, 4 meters in z. Now looking at point C. So in the x direction, we have -6. In the y direction, we have -3. And in the z direction, we have 6. So what do we have there? We had -6x, -3y, 6z. Finally, D. What do we have there? We have, scroll up. We have 4 in the x direction, -3y, positive 4, 4, -3, 4. So very similar to our B vectors there. We have our point. This is step 2, finding those vectors. That way down there. So unit vectors. So we're going to have unit vector U, A, B equals 3, 4, 0.5. UAC. We have -6, -3, 2.5. UAD. We have, that's 4, -3, and 0.5 again. So if I find the magnitudes of these, so the magnitude UAB, this is really, sorry, get rid of my U, they're really R's, so position vector. So RAB, the magnitude of that, RAB is going to be the square root of 9 plus 0.5 squared, 0.25. So it's going to be something pretty close to 5 when I work that all out. And if I divide this vector by this magnitude, I'll get a unit vector. So UAB is going to be that unit vector. I've got to mess this up here. I'll try to keep it relatively short. 597I plus 0.796J plus 0.0995K. So that's my unit vector UA. RAC can equal something similar, so square root of that, 36 plus 9 plus 2.5 squared. What is that? It's going to be something on the order of 6 or 7, I think. Let me pull up my calculator. 2.5 squared, 6 1/4. And if I find that and divide that out to UHC, may equal, so I have negative 0.838I minus 0.419J plus 0.34. That's UAC. So RAD, square root 16 plus 9, 0.5, same values. So UAD equals, it's going to be very similar, we'll switch around 796I minus 0.597J plus 0.095K. All right, so there's our unit vectors. Let's see where we go from there. So we've got our free body diagram done. We found our unit position vectors, unit vectors. Now we're going to apply. We know the forces times those vectors. We get these kind of crazy things, but it'll hopefully make a little more sense when we do it here. So we're going to apply the equations of equilibrium. So let's start with Z. This is step 4. Z direction. We're going to have the sum of the forces. Z equals 0. It's going to equal negative, what was it, 20 kilograms times 9.81 meters per second squared. So what are the Z components here? We're going to have plus 0.0995 F. I'm just call it FB. So from this one, there's that component plus the Z component for 3492 FC plus 0.0995 D is one of our equations of equilibrium. If I compute this and move it over to the other side, I find that this is down to 2.5 newtons equals that part, so 0.0995 C plus 0.3492 FC plus 0.0995 D. But this is the direction. In the x direction, so sum of the forces in the x direction equals 0. So what we have there, it's going to add up all those components. We have 0.597 FB plus what we have in C direction, we have negative 0.838 FC plus 0.796 FD. So I'm describing this component, and this component multiplying by their vectors there. And then finally in the y direction, so force in y is 0. So we're going to grab the middle section of these, 0.796 FB plus negative 0.419. Oh, sorry, didn't mean to scroll on us. FC plus negative 0.597 FD. So we got those here, and the other one's up. So we have 3 equations, 3 unknowns. We have enough information to solve it. You can pick from this point how you want to simplify that. I started, let's see, where did I get? So I started with the Fy, and I solved this in terms of B. So if I apply these other two to the other side, I'll have the same with Y here. So I'm going to have 0.796 FB equals 0.419 FC plus 0.597 FB. So I grab these two terms, throw on the other side of the 0. So I can divide by this 0.796 now. So I find FB equals 0.419 FC plus 0.597 FB over FB. Oh, excuse me, not over FB. 0.796. So I'm dividing by that. So there's that part. I'll come back. I'll substitute that into the other equations. I'll also come back and solve that at the end. I'm running out of space here. So if I take that, I fill that in with the x direction. I'm going to take this part here and put it in here and rearrange that. I won't go through all the math, but x direction, sum of the forces in the x direction equals, when I simplify that down, I should find okay, so I found 0.5238 FC equals 1.2 4, 4, FD. So that means FC is 2.374 FD. So then I'll substitute that in to that guy as well as in this guy. So it gets a little messy. Now I'm going to take both of these and substitute that up this way. And that way, so I can substitute that back into, into this one. And then substitute FB for FB in there and FD there. So if I keep working with that, finally I can get numbers in my Z direction. So if I in the FZ direction, so I have the 196.2 newtons equals, what is it, eventually find. So when I substitute these values in to the Z direction, I found that equals 1.127 FD. So FD then equaled 174 newtons. FC, so substituting here, pulling down, I found that to be 413 newtons. And FB, equaled 348 newtons. So it's a little tricky with the math. I didn't do all the math here. You just have to be careful solving this system of linear equations. Pretty straightforward, pretty easy algebra 2 type stuff. But you need to be careful in your signs and in your substitutions. You should find these answers when you're finished.